Hi students, welcome to this video session. My name is Samuel Chukwuemeka. In this video session, we shall study random sampling, and we shall specifically explain simple random sampling. The PowerPoint of this video, as well as the link to this video, will be on my website www.samuelchukwuemeka.com. So we shall have an overview of random sampling. Then we shall discuss simple random sampling. We shall then solve some applications involving simple random sampling. So what is random sampling? Random sampling is defined as a sampling method in which a sample is created by randomly selecting individuals from a population. As you can recall in the first video that we did for this class, Applied Finite Mathematics, we studied statistics. We defined population as the entire list of individuals that are being studied. Then we defined sample as a subset of the population. Sample is a subset of the population. It contains some of those subjects of interest. Now, the entire subject of interest being studied is the population. And then the subject of interest, a particular subject of interest, is called an individual. Why are we studying this anyway? Whatever profession you may be, especially if you run polls or surveys, if you're a journalist, if you're a reporter, if you're a writer, if you're a statistician, when you take surveys, when you run polls, and you want to report your results, it is very, very important that you do it well. Usually, it is a Herculean task to take a survey of a population. Now, the size of a population is usually very, very large. And to take a survey of that population is difficult. For instance, let's say now, consider the state of New Hampshire. You want to know whether the state of New Hampshire, how many percent support background checks on buying a gun, right? So you want to take the survey of the entire population of New Hampshire. It is going to be very difficult. It is going to be a tedious process. So what you want to do is to take a sample from that population. So when you take that sample, you don't just go to a particular county in New Hampshire, or maybe you go to a particular city, probably those of them that support background checks or those of them that do not, and then just run that survey there. No. You go and take random samples. You take random samples of the counties, and then in the counties you take random samples of the city, and of the city you take random samples of the neighborhood. Okay, so that method by which you now take samples from a population, right? You take samples from the population. When you now go to the neighborhoods and you now sample individuals, okay, to include in the sample so that you can now infer on the population. That method is what we call random sampling. Now, types of random sampling include simple random sampling, systematic sampling, cluster sampling, and stratified sampling. For this video, we shall only talk about simple random sampling. What is simple random sampling? Simple random sampling is a type of random sampling in which every individual in that population has an equal probability of being selected. So, why do we do this? Okay. Let's say you come to the city of Montgomery, state of Alabama, and you want to know the percent percentage of the city residents that love baseball. You want to just take a survey of whether the residents in the city of Montgomery, whether they like baseball. Okay, and you go to the Montgomery Biscuit Stadium. That's the baseball stadium we have in the city here. And you go there maybe on a baseball night, and then you now start taking surveys of the people that came, of the audience that came. That is bias. Okay, that will lead to bias, because everybody, those in the stadium, does not represent the city. I mean, they are not a true representative of the city population. So if you want to take samples, right? You want to take individuals to be included in your sample. It should be randomly selected individuals that will be a representative of the population. You go to baseball stadium, you go to hospital, you go to different neighborhoods in the city, and you select randomly individuals, you randomly select individuals from those neighborhoods, and then they will participate in the survey. Before you can now infer it on the population, okay, that 70% of the residents in Montgomery like baseball, or that 20% like baseball, you know, before you can now do that inference. Another example, maybe, let's take a good example, 2012 presidential election. Some polls had Mitt Romney as leading with a very high margin. Some polls had Barack Obama as leading with a very high margin. And they questioned the validity of these polls. Now, some of these polls are biased. They have a lot of bias because, okay, you want to run a poll of, okay, how many percent support Barack Obama, or how many percent support Mitt Romney, and then maybe you go to a heavily red state, and in that heavily red state you go to a city that is probably 90% Republican, and then you run that poll there in the city of that state. Now, and you now take the results of that poll to now infer, okay, that this is 90% of Americans support Mitt Romney. Or maybe you go and take a survey you run in a heavily Democratic city, right, in a state, and now say 95% of Americans support Barack Obama. That is bias. So this is a very careful job, right? And whatever you do, this course will enable you to know the right samples to take. We have to take, when we are dealing with simple random sampling, we want to take individuals, the sample that we want to create from the population. We want to take individuals that will be representative of the entire population, because we know that when we take these individuals and we measure some characteristics of these individuals in the sample, we are now going to do what we call inferential statistics. We will infer, okay, we will infer these characteristics on the population. So before we do that, we have to be careful to make sure we randomly select individuals. What do we mean by randomly selecting individuals? It means that every individual in that city, whatever city you're taking the survey, or whatever state you're taking the survey, every individual should have an equal probability of being selected. That ensures that randomness. And this randomness ensures that the characteristics of the individuals in the sample is a true representative of the characteristics of the individuals in the population. Now, before we use simple random sampling, it is important that we, first of all, list the entire individuals in the population. Now, this might be a difficult process, but it might be a difficult task. But if we are going to use this type of sampling technique, we have to. So this type of sampling technique is not it's not all and all, okay? Because sometimes we will have to deal with situations whereby the population size is so large that we can't even list all the individuals in the population. Remember, in this sampling technique, we have to list the entire individuals in the population. So, but one good thing about this technique is that it is like a base. It leads to other complicated sampling techniques. There are several sampling techniques that we can use, okay? But this is like the basic, and it ensures that randomness. It ensures everybody having equal probability of being selected, giving everybody a chance to be selected. So we have to list the entire individuals in the population. That list is what we call a frame or sampling frame. Then we have to ensure that the way we do it, that the way we now select these individuals to be included in our sample to be surveyed, that every individual will have an equal chance, equal probability of being selected to be included in the sample. Now, it is also recommended that when we list the individuals in the city, in the state, that we list the names in ascending order. Mathematics is all about order. Statistics is all about order. So it is important that we arrange the names, probably the last name first, before the first name, in ascending order. And that we use the without replacement probability condition. This is done in order to minimize bias. What do I mean by without replacement probability condition? Okay, let's say you want to select, you have in a classroom of 50 students, you want to select 20 students to go for a field trip. Maybe let's say the bus couldn't contain everybody, assuming. Okay, you write the list of the 50 students, you write their names, you arrange it in ascending order. Then what you want to do now is you want to kind of write their names, each of their names on a piece of paper. You write it on a piece of paper, you fold it, you write another one, you fold it, you write another one, you fold it. And then you put these names inside a basket, right? And then you now close your eyes and you make some drawing. Just like you see with a raffle ticket, raffle draw, right? You close your eyes and you call somebody, or you just close your eyes and you make a selection. And now, usually it's good to, as you write your name, to give them numbers. It is good. But you make a selection. That's one student, right? You don't replace it back in the basket. You don't. You now put it away. That student has been selected to now go on the field trip. Okay? You don't go and replace it back, because if you replace it back, okay, and that student is selected again, okay, will he be the same person appearing twice to go to the field trip? So that is minimizing bias. Okay? That is minimizing bias. We don't want to replace that. We want to select and then without replacement. So how do we obtain simple random samples? We can obtain simple random samples from a population by the following ways. We can list and pick, like what I just described. You list the names, right? You list the names in ascending order. Well, let me say alphabetical order now. In this case, with names. I'm sorry, I said ascending order. Well, that's fine. You list the names in alphabetical order, right? And you can start with A, B, C, ascending like that up to Z. And then you now write it on a piece of paper, and then you just put it on a piece of paper and then you pick, right? That's one way to do that. I mean, you shuffle, you pick. That's a simple random sample. Now, another way you can do it is all the names, right? You assign numbers. Okay, you assign numbers. Maybe this student name, you give him number 1, this student name number 2, this name number 3, this name, number 4, and you assign all these numbers for the 50 students, and you now decide to use a table of random numbers. So you have a table of random numbers in front of you, and you close your eyes, and then you make a pick. Like you just use your pen or pencil and you mark on a spot. It might be the 3rd row and the 5th column. Whatever that spot is, right? You now begin to go from there. Now, another way we can do this is, we're going to do some examples so I can show you how to use the table of random numbers. Another way we can do this is by technology, using technology. There are several technology that we can use to solve this. We shall talk about it as we go on in this video. So let's look at questions. Question 1. Students at Southern New Hampshire University were asked to pick 3 songs from a list of 9 free songs available for download. The songs are labeled Song 1. That's Song 1 is number 1, Song 2, number 2, Song 3, number 3, Song 4, number 4, and so on. What ways can they pick these songs? That's the first question. So, first of all, they can write, first way they can list and pick. They can write Song 1, write on a piece of paper, fold it. Song 2, write on a piece of paper, fold it. Song 3, write on a piece of paper, fold it. You know, write up all these up to Song 9. And then you close your eyes, you shuffle it, you close your eyes, and you just make a pick, right? And maybe you pick the first one, Song 3. You throw it out. You don't replace it. Without replacement now. Don't replace it. You throw it out. You close your eyes again and pick another one, maybe Song 4. You throw it out. Close your eyes again, pick another one, maybe Song 1. Throw it out. That's it. You've picked up 3 songs. Another way you can do this is to use a table of random numbers. Right? That's the second way you can do it. And that's the next thing they asked us to do. Then you can also use technology to do this. So 3 ways you can do it. Now, if they have to use a portion of the table of random numbers written as this. So in this case, they got a portion of the table of random numbers. They gave you the numbers. And if they have to start on the left and take the first 3 numbers between 1 and 9, what 3 songs will be selected from the labeled list? Okay, so first of all, you consider you have to pick a song between 1 and 9. So 1 is a single digit, 9 is a single digit. So you can't pick 10, right? Because it's between 1 and 9. So whatever you pick should be between 1 and 9. And if you will say it in inequality, it will be 1 is less than or equal to x is less than or equal to 9. Let me do some algebra if you don't mind. So if we have it in inequality, it will be 1 less than or equal to x, then less than or equal to 9, which tells you it could be 1, 2, 3, 4, 5, 6, 7, 8, 9. It should not be less than 1. There's nothing like Song 0. And it should not be greater than 9. There is nothing like Song 10. There is nothing like Song 10. So this is a single digit. This is a single digit. So we go ahead and start. And we have to start on the left, right? So 5. 5 is the first guy. 5 is between 1 and 9. So we pick it, Song 5. Right? Then 1 is the next one. 1 is between 1 and 9. We pick it. Now, I hope you know in inequality, this means less than or equal to. So this is equal to ensures that 1 is included. And this is equal to ensures that 9 is included. Now, the third one, 1. That's a problem here. This tells you that they did not do without replacement. Remember, we have to do without replacement. When we pick 1, we don't have to pick it again, so that we don't give the same individual 2 or more surveys. We have to avoid bias. So this won't work, this won't work, this won't work. The next one is 6. So this tells you we pick number 5, which corresponds to Song 5. We pick number 1, which corresponds to song 1, and we pick number 6, which corresponds to song 6. Those are the 3 songs. Now, as you can see, closing your eyes, the result, right? The outcome you will get by closing your eyes and picking, the outcome you get by list and pick, it's not the same. It's not necessarily the same outcome you will get from the random tables using a table of random numbers. And it's not necessarily the same outcome you will get when you use technology. This is why we say it is random, okay? It's not constant. It changes all the time. Okay. And even if you pick this by list and pick, if you shuffle it again, if you replace everything back again, and you do that the second time, you may not pick the exact same thing you picked the first time. Okay, so I hope you understood it. Now let me erase all this ink on the slide, and let me go to the next slide. Okay, question 2. The manager of Samdom Apartments has a list of the names of the 550 residents living in the east wing of one of the apartments. It intends to conduct an opinion survey of resident services, and he wants a sample of 7 residents. So he wants 7 out of 550. What ways can he select the residents? He can use the list and pick method. He can use, now this list and pick method, I don't know, I coined it up. He can use table of random numbers, or he can use technology. Then, assuming he wants to use the table of random numbers in the next slide, so he closes his eyes and he points his pencil to the 3rd row and 2nd column, and then keeps on downwards. What numbers would he pick? Okay, here, what are the options we have here? Let's look at the options we have here. He can pick, there is nothing like 0 resident. So he writes the list of all his residents, the names, right? And he numbers them. Resident number 1 is so-so person, so-so person. Resident number 2 is so-so name, so-so name. Resident number 3 is so-so name, right? So he can, and he numbers them. Number 1, this name, number 2, number 3, number 4, number 5, up to number 550. So he has between 1, and I can use Y in this case. I mustn't use X. He has between 1 and 550, where Y is the number of residents. Okay, Y means the number of residents. Okay, so the highest digit here is 3 digits, 550. So we are going to be dealing with three numbers. Okay, we can't deal, now I want you to understand this. We can't deal with only single digit, no, because the highest digit is 550. We look at the highest digit. That's the sample size of the population. Yeah, the sample size of the population. That is what we look at. If the sample size of the population is just single digit, like in question 1, the sample size is 9, right? And we have to pick the population size is 9, and the sample size is 3. But we are not really concerned about the sample size. We're concerned about the population size. In question 1, the population size was 9, is a single digit. So we can have 10. In this case, the population size is 550. And he wants a sample size of 7. 550 is what our main focus is, 3 digits. So we have to go with 3 digits. Now, we might come along 001, right? And that will now be the first resident. Because if you have 3 digits, the numbering will now be 001, 002, 003, 004. Okay, so we always look at the population size to know where to start from. And then it tells us here that it's going to be the 3rd row and 2nd column. So let's look at third row and second column. We want numbers between 1 and 550. And it's going to be 3 digits. Right? Okay. So let's go to the next slide. So now look at the table of random numbers. And it says third row, this is the row, and then this is the column. This is the column here, and this is the row. So third row is this, and then second column is this column. This column right here is the second column. This. Okay, so third row and second column will, if where they intersect is down here. You see that here? This is where they intersect from 1. So third row, second column, 1. So we have, and we know it's 3 digits. So we have 145. 145 will work. Okay, let's underline the ones that will work. So 145 is going to work. Then 757. 757 is greater than 550, so it won't work. 682 is greater than 550. It will not work. 190 will work. 190 is less than 550. So this means the 145th number, whatever his name is, we will give him a survey. The 190th number, whatever her name is, we'll give her a survey. Then the next one is 976 will not work. 682 will not work. It is more than 550. 404 is less than 550, so it will work. So the 404th person, we will give her a survey. Whatever her name is, we'll give her a survey. The 404th person. 814 will not work. 422 is less than 550. Will work. So the 422nd person will receive a survey. 536 is less than 550. Will work. 536th person will work. Will receive a survey. 610 is greater than 550. It will not work. Now let's see whether we've reached up to 7. We've not. 1, 2, 3, 4, 5. Okay. 610 will not work. 815 will not work. 500 is less than 550, so 500 will work. The 500th person will receive a survey, right? So 1, 2, 3, 4, 5, 6. Then 554. 554 is greater than 550. It will not work. Then 044. 044 here. The 44th person will work. So the people that will receive a survey are the people that whose names correspond with the numbers 145, 190, 404, 422, 536, 500, and then 44. Remember, we first of all locate the third row and second column, and then we'll have to do 3 digits. We have to read from left 3 digits, 145. We can't just read 1. No, we can't do it that way because the population size is 550. We have to give everybody equal chance of being selected. So we cannot just give only people with single digits. Otherwise, they would be selected, and then we will overlook those with whose names correspond to double digits like 25, or whose names correspond to triple digits like 550 or 500. Okay, we have to give everybody equal chance. So 44 is lucky here, 044. So that's the way we do it, and then these names, the names of the people corresponding with those numbers will be given surveys. Okay, previous slide. The last question. The manager later decided to use technology. What will he do? So that takes us to technology. The last slide. Use of technology to determine simple random samples. We can use these technologies to find simple random samples from a population. They are Microsoft Excel, TI-8384+, the Minitab software, Pearson StatCrunch, IBM SPSS, and much more. For this video, we shall only use Microsoft Excel. So let's see what we can do. Now, remember, we want 7 residents from a population. We want a sample of 7, sample size of 7 residents from a population of 550 residents. Okay, and we're gonna consider between resident number 1, resident name number 1 to resident name number 550. Okay, let's see how we can get this with Excel. Let me discard the ink. So I have Excel here on my computer. I think this is Excel. This is Excel 2010. But you can use with Excel 2007. It doesn't matter. So there are 2 ways to do this actually. But I will tell you about random numbers with Excel. The first thing we want to do here is you make sure that your data. You click on data. You make sure that your data analysis pack is installed. There is a video I did on how to install this, assuming it's not installed. But look at the way you do it anyway. Assuming it's not installed, you go to File, because if you have an Excel, they don't install it unless you do that. You go to Options, and when you go to Options, you go to Add-ins. And when you go to Add-ins, you see here, Manage Excel Add-ins. Go, you click on Go. And then this is the add-ins that are available, Analysis 2-pack. And you see it is checked. If I uncheck it now and click OK, it leaves. It goes. Okay, but if I want it back, I go to File, I go to Options, I go to Add-ins, I go to Manage Add-ins, I click on Analysis 2-pack, click OK. Okay, so when you are here, you click on Data Analysis, and it brings you straight to random number generation. Random number generation. So you click, it is highlighted already. You click OK. And then number of variables we are looking for. Variable here is the residents in your residents in the apartment. The number of residents is just 1. Number of variables, that's the residents in the apartments. Number of variables is 1. It is a quantitative variable. Then number of random numbers, right? We want how many random numbers? We want 7 actually. We want a sample size of 7. But with one thing with using technology is that sometimes it repeats itself. So I know we want 7, but let's make it like something like 12 or 13. Let's make it 12, because if it repeats, this Excel uses with replacement. That's the problem. So if we encounter a number that repeats, then we discard it. We discard the second value. That's the second similar number. Under distribution here, you want to click on uniform distribution. Now, why do we click on uniform distribution? We want equal probability. We want all the individuals in the population to have equal probability of being included in the sample. And uniform distribution ensures that. Then between 1 and 500. So 550. 550 was what we got, right? Okay. Remember, we want 7, but we just put 12 in case. We just put 12 so that we cancel out any one that repeats itself. Okay, the random seed. Random seed is just a non-zero number. Any number that is not 0, that it's like an initialization point, right? An initialization point. You can put any number that is not 0. I can put 3. Okay. Then we want it on a new worksheet, so it's probably gonna come up in sheet 4. we have sheet 1, sheet 2, sheet 3. We're doing this on sheet 1, but our results will come up on sheet 4. And then you click OK. So on that sheet 4, you see it right here. So it came out in decimals. Don't worry about the decimals, okay? We will discard all the numbers to the right of the decimal place. We are dealing with only integers. So we have 1. Resident number 1 will be surveyed. Then 121 will work. Of course, everyone will work. It's just that if it repeats, then you don't use it. Then 156. Then 153. Then 118. Then 396. Then 297. Then 394. Okay, we stop at 297. I'm sorry, because we only need 7. So this is 1, 2, 3, 4, 5, 6, 7. So these are the 7 residents. That's the 7 residents whose name correspond with these numbers will now be surveyed. As you can see, this is random numbers. So this is a random sampling. What we got from list and pick is different from what we got from the table of random numbers, and it is different from what we got from Excel. Now, let's say you're just playing and you just want, let's use sheet 2 since we've not used it, and you just want to just pick a number, maybe you are doing a game, right? Pick a number between 5 and 9. You just want one number between 5 and 9. Maybe let's say you need just one number right away. Okay, you can use Excel to do that. You just click on this function, insert function, fx, and you just type random. Type random, or it's either you type random and press enter. It comes to run between. Or you can type random number. You can also type random number. You want a random number very fast. Okay, so you see rand, it tells you what it is. Returns a random number greater than or equal to 0 and less than 1, evenly distributed. This is not what we want here. You click on rand between, bottom and top. Returns a random number between the numbers you specify. So let's specify a number here, maybe between 5 and 9. Okay. Now, I think it wants the rand between. So you want the random number to be there. Let's put it here. Let's put the random number here. Let's see what it will be. Then we click on this, the insert function. We click on rand between, and then you click OK. And bottom. Bottom is the smallest integer. Rand between will return. Yeah, bottom is any number. What is that bottom here? Now it says is the smallest integer. Rand between will return. So let's make this bottom let's make it 5, of course, and then top here let's make it 9. Okay, so between 5 and 9, that's what it means, right? And then you click OK, and it returned 9. Okay, it returned 9. Now guess what? Do it again and you see what you get. That's one thing with random numbers. If you do 5, you do 5 for the top and then 9 for the bottom, and you do it. You see the next one, it returned 8. You see, so it's kind of random. Yeah. And this actually returned 9, not 5. So return 9 here and return 8 here. Okay, so return 8 here. So that's what we get. So thank you so much for listening to this presentation. I hope you understood it. Remember, for the Excel, we don't use this is just if you want a fast random number between something. Yeah, otherwise you use the data analysis here. Data analysis, random number generation, and then you do that. Okay, thank you so much for listening to this presentation, students, and you have a great day. day.